Most of my videos start with, look guys, I bought this cheap thing and it only cost like $1 and blah blah blah. And this is the case again. Guess how much this 4-pack of LED light bulbs cost? Okay, guess. That's right, $4. $1 each, and it's from a reputable brand, OSRAM, from Germany, and it's really nice. So here's a bulb I already modified. So look, it's OSRAM and warm white, 8.5 watts, etc. I modified it to have not such a wide angle. I glued on just a piece of the bulb. But I'm going to take this apart. This was only a test. I glued it on with some heat-resistant silicone. It works, so it was just a test. Now I can disassemble it so I can see what's inside. My main concern is that this really heats up and it's going above 70 degrees, and that is not really good. These light bulbs can fail if they don't have at least some ventilation. If they're in a closed lamp, then it's not so great. So let's see what's inside, and hopefully we can put this thing on a heatsink at least. So then the heatsink can keep it below 60 degrees, maybe below 50 even. So I'll just take this off if I can. This silicone glue holds really well. I think that's what they use inside too. So this is how it looks. And it looks like all the electronics is on this side. Even the capacitor is moved here, and the two wires here go directly to the bottom and the side. So hopefully I can just remove these two wires, connect them from top, and then the bottom can be fitted on a heatsink. Let me show you. These are from Intel processors, the stock ones that don't really keep the processor cool. It's really thin, but for an 8-watt light bulb it's perfect. It even has some goop on it, thermal paste. So yeah, hopefully I will put it on this. So let's undo the bottom first. Let's see if there are any components down there. I haven't checked yet. So let's twist it off with scissors. Oh, yeah, and let's pop this off first. That was easy. Okay. And oh, it seems nice. It's empty. So yeah, this way they are protecting the capacitor from heat, because this part gets really hot. This is the heat sink. So yeah, let's try to take this. Oh, I have to cut it with something. Let's see. Just gently remove it. This is not really glue, but it sticks enough that you can't easily remove it. If it was glue, oops, I broke it off. Perfect. If it was glue, it would hold on more strongly. There's a gap and the cutter entered the gap. Perfect. Yeah. I didn't anticipate that. Oh yeah, So now it should come off. I said it should come off. With force, maybe. Yeah, I think most of it is out, but I don't want to bend the circuit board, so I'll try to get all of it with my nails. Yeah. Yeah. Okay. So how do I do this to not bend anything? Maybe push it out from the back with a screwdriver gently, and let's see if it moves. Nope. 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 Oh, that's right. I think I'm doing it wrong. Where does the metal end? Does it end out here, where there's more glue? I need to see this. Here it's exposed. I think that's where it ends. This is the outer shell. And basically a plate is on it. That's the plate. But it makes no sense. It's usually not like this. So let's see. Let's break the blade some more. Ew. So this doesn't move. Maybe it's glued on. Let's cut away some more of this. Man, I haven't taken apart one of these yet, so maybe the first one I will break and then try again with another bulb. Okay, let's see now. Let's try to push the side. Up, it's moving, I think, but something is stopping it. I'm trying to move around. Ooh, okay, done it. So, yeah, perfect. This is awesome. I can just pull out these two. Oh, yeah, not quite perfect. There's this plastic, which is annoying. But I can pull out these two wires. Hopefully. They are in there tight. Oh boy. They don't want me to... Oh yeah. It's one of those grippy connectors. As soon as you push it in, it's gripped. So maybe I can twist it out and pull it. That's the only solution. Yeah. Look how deep grooves it left there. Focus. Can I show you? Here in my hand you can see. So this wire should be smooth, but it left all those marks as it was gripping it. Actually, this is not wire, this is a... how do you call it? A circuit breaker. Thermal fuse. Yeah, thermal fuse. If it gets too hot, this one breaks and it doesn't catch on fire. So let's do the same thing with the wire. This is just a simple wire. Let's try to twist it and pull, and it's working. Brilliant idea. Yes, and then cut off this plastic because we don't need it anymore. Hopefully I won't cut myself. Oh, it's moving. What do I do then? Maybe cut in a different angle so I don't hurt anything. Why does it move? I don't understand it. And it's heat resistant material, heat resistant plastic. Well, of course it has to be, because it's too close to the LEDs and power supply too. So can I cut it without doing too much damage to the surface of this aluminum plate? It's cutting into my hand almost. Oh yeah, in my hand. It's enough, I think. No blood yet, so I didn't cut myself. Perfect. So now maybe cut a little more carefully. I still have to use my fingers today and even tomorrow. Oh. Yeah, that's it. But here's another problem. I can't short circuit the two wires. So these will have to come out somehow. So this plastic can't go the other way, so it must come up. How can I do that? Push out those little... Let me show you. They are grabbing the plastic with those on the sides. And I don't know why they did it so complicated. It's not like somebody will try to disassemble it. Other than me. Yeah. I think it's coming out. So if I push it, yes, okay. It's coming out, and that's the trick. So I have to cut away some more here to expose the other leg too, so I can move it out of the way so it's not grabbing the plastic, like that, and push them out carefully, because this is maybe I can cut the stupid plastic in pieces. This is really stupid. Why did they do it so securely? Well, anyways, I'm not gonna waste your time with this. Let me just show you how it will look. So I can put it on this this side, and it will touch most of the LEDs and will touch the fins also. So it won't touch just the solid middle. Or I can put it here, the same thing, if you think it looks better. And yeah, it's not flat. Probably as I pushed it out of the casing. So maybe I'll have to glue it on Oh, this also moved. Nah, it's fine. Or some screws, zip ties. No, zip ties will melt. That's a bad idea. So some screws or that thermal paste that is also glue. So yeah, if this is really heating up, the heatsink will take care of that. And it doesn't need a fan. This thing can handle like 50 watts. And this little thing only puts out like, what's the efficiency of LEDs? Maybe 3 watts, 4 at best. Its total consumption is 8.5 and the efficiency should be at least 80%, I think. That's typical for semiconductors, I think. So it should be like 2 watts heat. Or maybe a bit more. Whatever, I don't care. This will it should be less than 50, okay? Yeah. So with this solution I can put this LED bulb into more dangerous places where there's not enough ventilation or it's too hot out in the sun in the summer when the sun can heat it up to 50 and then the additional heat this produces, yeah, it can add up. So yeah, this is a solution with a really cheap LED bulb, $1, and it's a good brand. Advanced chips here, look. If I can focus, can I focus on that? Let me try to show you what chips they are using. How can I do that? I'm out of practice. I don't know how to show you the chip. Whatever. You can find it online probably. With the serial numbers and revision numbers and brand name, whatever. Okay, so this will look like that. If I need to, I'll put on this part here and the Edison cap, I mean connector, what do you call it? Socket. And it can be put into a standard light fixture like that. And of course I'll have to wire the high voltage 230 here with 2 wires, and the 2 wires will come down here. So okay, this is very useful. Yeah, more noise. Okay, I'm gonna shut off the recorder now.